Unit 2, Learning Target 2, calculate the rate of change from a table. So we're going to stick with rate of change here and just look at tables this time. Okay, so we have an in-class investigation on the next page. You don't have to worry about that for today. We're just getting through the video notes. So the first, or the two definitions we're going to look at here, and this is just kind of building on the linear relationships notes that you took on the last video, are independent variable and dependent variable. And so an independent variable, we always have two variables in a linear relationship, and if you think about a graph of an independent or a linear relationship, or any graph really in general, you usually have the x-axis and the y-axis. Our independent variable is going to be here, and this is a variable whose values affect the values of another variable. Or more importantly, it's independent. All right, it is can stand alone. Okay, time is an independent variable a lot of the time. So because if you think about it, time always goes on. All right, nothing depends, or nothing. Time doesn't depend on anything. Time is independent. It goes on whether we're making money, whether we're playing sports, whatever we're doing, time goes on. So that's a good one that I like to think about, is which variable is affecting the other one. And the one that is affecting the other one is the independent variable. The one that will change regardless of what the other one does is the independent variable. And the other one then is called the dependent variable. It's a variable whose values depend on the values of another variable. So what happens is that the independent variable is the x variable, okay, and the dependent variable is the y variable, okay. So oftentimes time goes here, or number of something sold, or something like that, something that has to affect the dependent variable. So the money you make over time, or the money you make by selling something. And right now I'm only being able to think of money and time, or the distance traveled over time. That often is one that we use. But we'll look at some examples here. And but the big learning piece for today is that independent stands by itself. It affects the other variable. Dependent is affected by the independent. Okay, and that the independent is the x. It's always on this x-axis. The dependent is the y. It's always on this y-axis. So let's look at an example. The table here relates the approximate wind chills for the different actual temperatures in the wind speed is 15 miles per hour. Assume the wind chill is a linear relationship for temperatures between -5 and 35 degrees. So what we have here is just the temperature and then the wind chill. Okay, and I'm sure you guys know that wind chill often is kind of how the temperature feels, what you feel like versus what the actual temperature is. So usually when it's windy, it's going to feel colder than it is. So if we look here, we have -5. If that's the actual temperature, it feels like, or the wind chill is -25 degrees. If we jump up over here, if it's 35 degrees, then it feels like 25 degrees. Now keep in mind this is with a 15 mile per hour wind, all right? But we're asked, what are the independent and dependent variables here? So my question to you is, which one affects the other, or which one changes more independently? All right, so think about that in your head. And then I'm going to go ahead and say that the temperature affects the wind chill, okay? When the temperature changes, then the wind chill changes, okay? So it's going to be our independent, okay? And then the wind chill is going to be our dependent. And oftentimes, just kind of as a little cheat, oftentimes in tables, it'll go x on top, y on the bottom. So our independent is going to be our temp, and that's going to be our x. And then our dependent is going to be the wind chill, and that's going to be our y, okay? Then we're asked to calculate the rate of change. Well, to do that, I'm just going to look at what my x values are changing by and what my y values are changing by. And I see that this table is missing some pieces, so we'll have to fill those in. But first I want to look at, I have 3 points all together here, so I can get a good estimate of my rate of change there. So from -5 to 0, I go up 5. And from 0 to 5, I go up 5. And from 5 to 10, I go up 5. Now, this makes sense because if it's a linear relationship, you should have a constant rate. But then if it's truly linear, we're going to have a constant rate down here. So from -25.8 to -19.4, I'm seeing an increase there. And then I've already done the math, but if you see it right away, that's an increase of 6.4 degrees. All right, so from -25.8 to 19.4, what I did is I just took 25.8 minus 19.4, knew that I was getting to a smaller negative, so I'm increasing. And then here, -19.4 to -13, again, is another 6.4 increase. And so then let's just follow that and see if it matches up as we get further on over here. So if we used that 6.4 increase, then from -13 to plus 6.4 would be -6.6, and hopefully that's correct. Then if we're going to add 6.4 again, that would be -0.2. And then that makes sense. Then from -0.2 to positive 6.2 would be a difference of 6.4. 6.2 to it would be 12.6 would be another difference of 6.4. And then that matches up with 19 and 25.4. So our rate of change here is going to be the change in the y over the change in the x. And remember, this is y, this is x. So our change in y is 6.4, and every change in x is 5, both positive because we're going up for both. All right, so if we reduce that, that's 1.28. And again, I've already done that math for us. So that's 1.28, and that would be over 1. So now we're asked to interpret the rate of change. And you guys can write this down based on what I'm saying or what you think. But what I'm interpreting here is that this is a change in what? In the wind chill or the temperature? This is a change in the wind chill. Okay, so change in wind chill. And this is a change in the temp. All right? And I like seeing it as a fraction. So that means for every 5 degrees that the temperature changes, it changes 6.4 degrees in the wind chill. Okay, so there's more of a change in the wind chill than there is in the temperature, actually. So we can see that here. Here, this is over 1, right? So now we can say for every 1 degree of temperature, there's going to be a change 1.28 degrees in wind chill. So that could be either way. If it gets 1 degree colder, the wind chill, it's going to feel 1.28 degrees colder. If it gets 1 degree warmer, it's going to feel 1.28 degrees warmer. All right. So some kind of interpretation. Use your best judgment to kind of get down what I got there. You might have to listen to that again. But I'll let you use your judgment on that interpretation. Then finally, we're asked to calculate and interpret the starting value. Well, if you remember from your video notes before, the starting value is when x is 0, right? And luckily on this table, we have a spot where x is 0. So we know that if x is 0, then y equals -19.4. And we don't really have to calculate anything. We just know that that is our y-intercept. So in the equation part, that would be -19.4 equals b. That's going to be our y-intercept. Or our y-intercept. I'll write that too since the problem doesn't. Okay? And then let's interpret that. What does that mean? That means, well, when the temperature is 0, the wind chill is -19.4 degrees. All right? And then let's write a linear equation in the slope-intercept form. Well, we start at -19.4. That's our temperature that's our wind chill when the temp's 0. And then we're going to add, since our slope was positive, 1.28 for each one change in x. Okay? Now if we write that in correct mathematical form, the slope comes first, so 1.28x plus a negative or just minus, whatever you guys prefer, 19.4. That would be our equation. But again, today the learning target is just looking at this rate of change. But this equation will come in handy later. All right. So before class, why don't you try the following table, calculate and interpret the rate of change. What does it mean in terms of bottles and profit? And then start to think about what's the starting value and what does that mean as well.